So this is solving for a variable in terms of other variables. And so you're really not solving anything, you're just rearranging this formula. So we have this 9 equals y over x1 plus y over x2, and we're supposed to solve for y. So there's kind of two main ways that I can think of to do that. One is the way that they and Alex did it. That's kind of actually how I would probably do this as well. So I'm trying to pull up a whiteboard. Okay, that's not what I want. Oh, stop it. Okay. Hello. Okay, sorry. So multiply both sides by the LCD. So when you look at this thing, this equation, you have two fractions and two different denominators. And so one way to just be able to, I don't know, do stuff better, easier, is to get rid of the denominators. And so we're going to multiply both sides of the equation by an expression that would cancel x1 and cancel x2. So that's just multiply these together. So when we do that, we'll get the 9, will just be 9x1, x2. And then on the other side equals, okay, well, the first y, x1 cancels, but we're still going to have an x sub 2. And then for that second fraction, now x2 cancels, and we're still going to have an x sub 1. And so now we have the tricky thing of, okay, well, y is sort of in two different terms, and these are not like terms. So the only way to kind of separate it out is to factor it. So we have 9x1, x2, and then let's just factor y out as a common factor. So we're left with x2 plus x1. And so now we're going to divide by this, what's in parentheses, so that y is completely on its own. So when we divide by the x2 plus x1, it is going to cancel over here with the y. That way we're just going to have y. But over here we now have this kind of complicated looking rational expression. And so this is what you would type into the answer box. So just to give you some options, there's other ways that you could do this. Actually, now that I'm looking at this thing, I can actually think of at least two other ways that we could approach this problem. And so one way might be actually to go ahead and factor out the y in the beginning. That would leave you with a crazy looking expression once you finally get it solved. So I don't know, now that I've started talking about it, I'll go ahead and show you, but you might fast forward like 30 seconds. Okay, so if I factored y out, I can actually write this 1 over x1 plus 1 over x2. And then divide both sides by that. Now what's going to happen when we do that is we're going to end up with 9 over 1 over x1 plus 1 over x2. This is what we call a complex fraction because we have fractions inside of a fraction. And I think that Alex is going to not like this. I don't know. It might be okay with you typing it in this way, but this is considered to be unsimplified. So let me just let's just not do that. So let me erase. Ooh. And here's the other way that you might think of this. So 9 equals is what I'm wanting to put there. 9 equals y over x1 plus y over x2. Okay, so starting over again. So instead of multiplying through by this x1, x2 denominator, another thing we could try is actually just adding these two fractions. And so the common denominator is, again, x1, x2. And so if I want to get the each of these two fractions to be over that common denominator, so x sub 1. Oh, that's weird. What the heck did I just do? Okay, look, I want this one. X sub 1, x sub 2. Okay, then I would multiply by x sub 2 to get the x1, x2, but then I have to balance that fraction and also multiply in the numerator. So then over here for the y over x sub 2, I would need an x sub 1. And so we're going to get now 9 equals yx sub 2 plus yx sub 1 all over that common denominator, x sub 1, x sub 2. And it doesn't matter what order if you do x2 in the next one. And so now I could factor the y out. And I can actually factor it all the way out front of this expression. If you're factoring something out of the numerator, you can do that. You can just bring it all the way out front. And so then we'll have x sub 2 plus x sub 1 over x sub 1, x2. So then if I want to now, and I think this is by far the easier way to do it, the very first thing we did, but if I now want to get y by itself, I could multiply now both sides by the reciprocal. So dividing by a fraction is the same as multiplying by the reciprocal, and so that reciprocal of this thing would be x1, x2 over that x2 plus x1, so that everything cancels. And then I'm also going to multiply over here by that. And I can think of the 9 as being over 1 when I get to the next line, 9 over 1. And so finally we're going to get, okay, 9 times x1, x2. So maybe we could just put that 9 out front or up front. And then over the x2 plus x1. And then the whole point of all this was that all of that stuff cancels and we just have the y. So I think this ended up being, for this particular problem, this very first thing that we did and the way Alex showed it is actually the easier way to go. Oops. But it kind of depends on the problem, what's going to be easier. So it's helpful, I think, to kind of be flexible. But these are tricky. So just kind of keep practicing and remember it's just rearranging.